You ever stop and think about how your computer actually keeps track of everything? I mean, all of it. Your documents, your photos, your games. How does all of that stuff stay perfectly organized on just one single disk? Well, today, we're going to pull back the curtain and demystify that magic.
I mean, it is a huge problem when you think about it. We are talking about managing potentially trillions of individual pieces of information. Everything from a single character in a text file to a massive 4K video file, all without losing a single thing. So how does a totally blank disk become this perfectly ordered system?
The best way to wrap your head around it is with a pretty simple analogy. Just picture your hard drive as this enormous, completely empty library. Before you can even think about putting books on the shelves, you have to build the structure itself, right?
And that gets us to the very first step, building the main sections of our library. In the world of digital storage, we call these partitions and volumes. These are the foundational walls that create the large, distinct areas on our disk.
Yeah, and as digital forensics expert Brian Carrier points out, these terms can get a little tricky, even for people in the field. But at its core, a partition is really just a bunch of consecutive sectors on the disk, a defined physical chunk. Think of it like drawing a big line in the sand and saying, okay, this section, from here to here, that's one single area.
Your operating system then looks at that partition and sees it as a volume, basically a usable drive. This is exactly why you might have one physical hard drive plugged into your computer, but when you look at your files, you see a C drive and a D drive. That's just one disk that's been split into two separate volumes. Okay, so we've got our walls up. The library is divided into big sections. But how does the computer know where these sections are? Well, it needs a map, right? A master directory that sits right at the very front of the library. And this map is called the partition table.
And what's kind of wild is just how simple this map is. For every single one of those partitions we made, it only needs to know three basic things. Where does it begin? Where does it end? And what kind of organizational system or file system is being used inside it? That's it. This is the simple, elegant blueprint for the entire disk.
But, just like architectural blueprints have evolved over the years, so have these partition tables. We've actually moved from a much older, more limited system to a way more modern and powerful one. And it really tells a cool story about how technology evolves.
So the old system, MBR, you can think of it like a physical card catalog from the 1980s. It was amazing for its time, but it was really limited. It could only handle 4 main sections, or partitions, and couldn't even manage disks bigger than 2 terabytes. The modern system, GPT, is like a super powerful digital directory. It can handle up to 128 partitions and supports disk sizes so ridiculously large, we're probably not going to hit that limit for a very, very long time. And this table right here, this shows you exactly why the old MBR was so limited. The entire blueprint, the whole map, is crammed into just 512 bytes. That's it. And most of that space is for instructions on how to start the computer, leaving just this tiny little space for the partition table itself, just enough for those 4 entries. Now contrast that with the modern GPT. It is just so much more robust. It's got a protective entry for older systems, a header with error checking to make sure the data is intact, a huge table for all those partitions, and, this is the real game changer, a complete backup of itself at the other end of the disk. So if the main map gets damaged, the computer can just go, no problem, I'll use the copy. It's designed for resilience from the ground up.
So, we've built our library sections with partitions, we have our map. Now we need a system to actually organize the books on the shelves inside each of those sections. And this is where file systems come in.
A file system is basically the library's Dewey Decimal System. It's the set of rules that dictates everything: how to name a file, where to physically store its contents, and how to record all the little bits of information about the file, like, when it was created or the last time you opened it.
To really get this, let's zoom in even further. Let's look at a single book or a single file and see how the file system breaks its information down into different categories.
So, the file system sorts info into 5 main buckets. You've got data about the file system itself, the file's name, that metadata we talked about, but the one that's most interesting for our purposes, the one we really want to focus on, is content data. Content data is the actual stuff. It's the words in your document, the pixels in your photograph. The file system breaks the entire disk up into these little tiny data units, and it keeps track of the status of every single one. A unit is either allocated, which means it's currently being used by a file, or it's unallocated, which means it's free space, ready for something new.
And this brings us to a really fascinating question. We all do it, right? We drag files to the recycling bin, we click empty, but what is the computer actually doing in that moment?
And here is the big secret. The file's content isn't immediately erased. It's not overwritten with a bunch of zeros. Nope. The file system simply goes to its map, finds the little data units that belong to that file, and just flips their status from allocated to unallocated. The book is technically still on the shelf, but the library's catalog no longer has a card that points to it.
So, the crucial takeaway here is that your deleted data just sits there, perfectly intact, until the system happens to need that exact spot for a new file. This is precisely how data recovery software works. It just scans all those unallocated spaces, looking for the ghosts of old files. And for digital forensic investigators, well, this unallocated space is often a complete goldmine of evidence.
So, from the master blueprint of a partition table all the way down to the hidden status of a single little data unit, your entire digital life is built on these incredible invisible layers of organization. It kind of makes you wonder, doesn't it? What ghosts of data past, what forgotten stories could your own so-called empty space still tell?